Hello everyone. This is a probability lessons. Okay, we continue our probability lessons. Okay. Today we're gonna learn mutually exclusive events. Okay. Uh, the property of the union of two events. If we can, I'm gonna introduce you to formulas for this topic. Okay. The first one is here. If A and B are events in the same sample space, the property of A or B occurring is given by probability A union B will equal to, this is a formula, equal to probability A plus probability B minus probability A intercept B. Okay, and this the second one is if A and B are mutually, okay, this one should be separate, are mutually exclusive, then probability A union B will equal to probability A plus probability B. Okay, what the difference between these two examples? The first one, if they have, let's say, intercept. For example, if they have intercept here, okay, that means the event, the events A, or you can say the set A, okay, on the B, they will have the common uh, element or common objects. So then you're gonna have intercept. So gonna use the example. I mean this formula. In the second one, this one, if they are mutually exclusive, that means set A or set B or the events A and B, they are different. They have their own special looking. So it's like a set A and B, they don't have any common point. Then that means intercept gonna be equal to 0. In this case, actually, they just say like this one, minus probability A intercept B. That means this part will equal to 0. That's that means they don't have any common element or common objects. Okay, so that becomes 0. So actually, you just, if you want remember, just remember the first one. That means if no intercept, right? That can no intercept, then you use, we call mutually exclusive. Okay, that means intercept part equal to 0. That's all. Okay, so there's two formula today. Now we see example. I think this example is pretty good. For most of time probability, they will use the cards, okay, to be the example because they have uh, more object, more element to explain, right, and to ask for more questions. So when we see come to see the example about the cards. Okay, example this one. One card is selected from a standard desk of 52 playing cards. What is the probability that the card is either a heart or a face card? Okay, so then we first of all we come to see uh, the the standard desk card. Why they say have 52 cards? Okay, we see if I did not say gonna push you to pay the card, okay, but this is a good example to learn, okay, for the property. So you see, like a one desk, we have 52. In this case, they use only 52. They did not include the joker, right? So only count from one, but one they call as A. Okay, see this one A, this one. Okay, see, use another color here. Start from A, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you have 10, and then go the face cards that have Jack, Queen, King. Okay, so each one you see like a heart, right? For the heart here, the whole thing start from A, 2, 3, 4 up to King. We have how many? 13, correct? This one we have 13 cards, and also this one diamond, okay, diamond is a 13 also. You count from A is a 1, right? 2, 3, 4, 5, 6, and so on up to this one diamond. So also have 13, right? Because of A, so 1 up to 10 plus another 3, so 13. Also this one we call clubs. Okay, also 13. And this one spade have also 13 cards. So 13 times 4, right? 13, because we have four picture here. So you just use 13 times 4. So gonna have 52 cards. So we have 52 cards. So then, so we get that why they say 52 here. So we have 52 cards. Now, next we're gonna find the property of the card that is either a heart, okay? A heart, then you come to see this a heart. So in one desk, there will have two color only. Sorry, we have only red or black. So red card, we have the heart is a red, right? And the diamonds are red also. And then this a club have is black and the spades have black color. So for the heart is a red. Okay, so now I do this one like a one separate all the red cards, the red one. So we have heart and the whole thing here, A to K to king, I mean to king, jack, queen, king. Okay, so then this set all the red, which is a card have heart, red heart, and the from number 1 is the A 2 3 up to jack, queen, king. Okay, so and then this set, say we from this set you're gonna have what this jack, queen. So I like only because they want face, right? Question want us to find either a heart or a face. So the face card I will put in this set. Okay, face card that mean here, right? A1, see here. So only jack, queen, king. So they have 3 heart, red heart, and diamond red, and clubs, another 3 for each, and this one another 3. So the whole thing become what? 3 times 4, 1, 2, 3, 4 times 3, right? So this one become 3 times 4. So equal to 12. So the face cards, if you total up, equal to 12. Okay, I really like it. So this one gonna be 3 times 4. So equal to 12 face cards. Okay, now heart. Heart, you count from here. A, 1, 2, 3, up to 10, right? And then 2 jack, king, queen. So heart, this heart total is what? 13 also, right? This one have 13. And face card we have, from here we just count, we have 12. So from this one, you can see this part, the one that have intercept. I maybe use the yellow color here. I shade it up here. Okay, this area, okay, this part is the intersect part. Which have jack, queen, king, heart one, heart red. We intersect to this face card here. So this part is the intersect. So now in this question, you can back to see we have intersect part, correct? So now we do find the heart first, the heart card. So we have 13, right? 13. So we have to use this formula, the first formula, because we have intersect part, this one, the yellow color here. Okay, this intersect part. So then we do find the property of a heart first. So heart we have 13 out of, don't forget the probability of, the formula of probability is what? The P, probability of whatever we get, right? You have to get the NE, right, over the total probability. This for property event. They use what NE and the total probability TE. Okay. From period, we just find out the total, the how to say, the total one, total object what we have. Okay. So now this one we have the hard card is 13. So total of the card is on in one desk is over 52. And the face card is what, 12, right? So we have this one become 12 over 52. So you're gonna have this one P of heart equal to this, and P of face card equal to this. Okay. So then just say this we got P of the heart is a heart, right? And probability of face card equal to this. Then this one you can use the first formula here, right? The first formula here. Okay. So PA like a P of heart, probability of heart, plus PB, the probability of face card. Okay, so plus that, so we plus it up. And then minus P of A mean the hard card, hard card, right? And the B is the probability of face card. So that's this one is the intercept. Okay, we have intercept how many? 1, 2, 3. So we have this one, the probability A intercept B become, this one is a PA, just say P of hard card intercept with the face card. So final we write down become 13 over 52 plus 12 plus 52 and minus this the intercept hard card and the face cards. So become this section, the yellow shaded here. So it's a 3 over 52. So now you simplify become become 13 plus, because the same denominator, correct? So we just add it up and minus this one. So over 52, because the same denominator. So become 25, take out 3. So we left 22 over 52. Okay, and then you can leave this one as the answer, it's okay, right? You can leave this one as the answer or find out as a decimal point equation, request for the decimal point. So if decimal point is the approximate calculator 0.423, I think, yes. Okay, that's a final answer. You can leave at the answer the fraction or decimal points, decimal places. These are 3 decimal places, 0.423. Okay, so now this the example for mutually exclusive events. Okay, that's the example, is an example to learn. And then I suggest you you still have the old handout we have, right, on hand. So if you want to practice, you go to the exercise 8.7, question 21 to 24. Okay, so at this next 2 weeks learning, I may not correct your work, but you can just learn and remember the formula here. But I have the question for suggestion for learning here. So if you want to practice, go ahead, do it. Okay, this one. This one on the page 657 on your handout, 657. Okay, if you need help for the solution, you can lie or ask, okay, individual or lie group, and I can explain for these 4 questions. Okay, so just practice it. I think it's a really nice and probably can be in your SAT exam also. Okay, okay, I think that's all for today, and then I will give you more example and the more formula, and then I think anyway it's useful for you. Okay, and we can finish all the things we should learn for this semester. Okay, see you next time. Bye bye.